All right, this is Algebra 2 Honors, Other Common Intervals of Functions. And so we are going to be looking at intervals of increasing and decreasing right here. We're going to be looking at intervals where functions are positive and negative. And then a couple of other things. We've already had domain and range. And so you are going to be using interval notation with parentheses for increasing and decreasing intervals. You'll see me abbreviate that INC DEC. And you'll be using a mix of parentheses or brackets for positive, negative intervals. You use a lot of parentheses in positives and negatives, but there are occasions where you have to use a bracket. The intervals are always about the x values. The intervals are always about the x values. Always, always, always. Okay, for increasing and decreasing, again, always use always use parentheses. So no matter what the value is, you always have parentheses as you describe in increasing and decreasing intervals. Always parentheses. And a function is increasing for any x values whose y values are going up. They are increasing for any x values whose y values are going up. So we're looking where the y values are going up, but my answers are about x values. But they're going up as you go from left to right. There is an order. As you go from left to right on the function. And so that looks like starting on the very left, move along the graph, trace it as from the left. Notice on that interval I was going up, but then as I continue, I'm going down. You cannot, if you start at the right and go to the left, you get exactly the opposite answer. So you have to follow the order or you won't get the correct answer. You always are thinking about the function is going up if I am driving on along it. So I've got my little car here, That's my car. And it's going from left to right. I am going from left to right. I'm going up, 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 up. On that interval, that is an increasing interval. So you got to always think left to right. So I'm coming from a left value of x of negative infinity. And until I get to this point, which at this point right here, that is a relative max. The x coordinates of relative max and mins are what you use to separate the intervals. The x coordinates of relative max and mins are what you're using, along with the farthest point on the left and farthest point on the right. And so the x coordinate of that relative max right there is 0. So that's the value that breaks up from increasing to decreasing. So use parentheses and use x coordinates of I should say relative. As well as far left and far right x values. And so once again, as I drive from left to right, I'm going up, 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 up. And so I have an increasing interval from negative infinity to 0, and you always use parentheses. You're not going to ever include any value on increasing, decreasing. For decreasing intervals, the decreasing interval is any x values whose y values are going down. Again, as you go from left to right. So as you start at the left part of the function, I start by going up, up, up. That's an increasing interval. And then at that relative max, we're going to start going back down. So that's the interval where we have it decreasing. So from here and so on, we have a decreasing interval. And it is the x value of that relative max, that point that is the highest there. It is the x coordinate and then to the right to positive, to positive infinity. That is your decreasing interval. So 0 to positive infinity. And again, when you write intervals, it's always the smallest value on the left, the largest value on the right. So increasing and decreasing interval for that diagram are written there. And then you have some places where the function's not increasing, it's not decreasing. And so the point at which the function changes direction is the place where the function's not increasing, it's not decreasing. And so that is this point right there. That's why we use parentheses. A function can't increase or decrease at a single point. It has to have an interval of values in order to show that y values are going up or going down. So at a single point, a function can't be determined to be increasing or decreasing, so we're going to use parentheses there. And interestingly enough, we can determine if you have a high point or a low point, a maximum or a minimum, according to how the function is increasing or decreasing. What? Well, on this function, we're going up, 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 and then we change to down, 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 down. That kind of process, and always assuming going from left to right, if you start by going up and then you go down, is going to create a maximum. It has to. We are agreeing that we are going from left to right. So if you go up, 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 and then down, 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 you are going from increasing to decreasing, which this function does. You're going to have a maximum. On the other hand, if you have some graph such as this, and we start on the left, and this is going down, 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 and it changes to up, up, up. It changes from decreasing to increasing as you go from left to right. That is going to produce a minimum. That's going to produce a minimum. Oops. And so that's this example right here. In AP Calculus, this is important because that is actually how you are going to describe and justify how you know a point on a function is a max or a min. You're going to say at this point the function changes from increasing to decreasing, so it's a maximum, or you're going to say at this point the function changes from decreasing to increasing, so therefore it's a minimum. That is going to be a concept that you need to know there. And that's how you write in words to justify it. It's pretty cool. Already looking at stuff for AP Calc. Yes. That's why we're covering it. So at the point where it changes direction, it's not increasing or decreasing, hence the parentheses. All right, positive and negative intervals. You are going to be using the far left x value, the x-intercepts, also referred to as zeros, of the function, and the far right x value. Those are going to be the key values that are going to break up your positive and negative intervals on your function. And again, you're going to be using a mix of parentheses and brackets. Mostly parentheses, but there are occasions where you need a bracket. And so a positive interval is any x value whose y values are above the x-axis. Any x values whose y values are above the x-axis. And so we are going to use the x-intercept of -3 and the x-intercept of 3. This gets wider and wider, so the far left x value is -infinity. The far right x value is positive infinity. And so if I'm going through here, we've got -infinity is the far left, -3, +3, and then positive infinity is the far right. Those are the values that are going to break this up for where this is function's positive or negative. For where the function is positive, our x value whose y values are above. And here the y value is above. The function's above. But it is these x values for which this function is negative. For which this function is positive. Even though those x values themselves are negative, the y values are positive. So for this set of x values, the y's are positive. Those x values are an interval where the function is positive. So the function is positive from -infinity to -3. This is, it goes above the x-axis for those. The function is also positive over here because for these set of x's, it's above the x-axis. The y values are above the x-axis. So for these x values, this function is positive. And so the positive interval is -infinity to -3. At -3, because the y value is 0 and 0 is not positive or negative, we don't include -3. We don't include -3. We never include x-intercepts. These always have parentheses on any x-intercepts. Make sure that you've got it pointed to x-intercepts. Because the y value is 0 and that's not positive or negative, you will always use a parenthesis for positive and negative intervals for any x-intercept boundary. And so for where's this positive, it's -infinity to -3, and then union 3 to infinity. Again, the u, it's kind of a flattened u, it's a little wider, and that is a union symbol. It means or. This or that. And then close up that interval with a parenthesis. So that's the interval on which this function's positive. The x values for where the y's are above the x-axis. For negative, any x value whose y values are below. And so again, we have -infinity, we have the x-intercepts of -3 and +3 and then positive infinity. And for all of these x values, the graph is below. So the x values for which the function is below are, it's supposed to be an n for negative. See if I can get just the n to disappear. Nope, I can't do it. Okay, so just rewrite it. It's negative for those values, the x values between -3 and 3. So your negative interval is -3 to 3. And -3 and 3 are both x-intercepts, so they have to be parentheses. The function is not positive or negative there. It isn't. All right, for neither, any x values whose y values are on the x-axis, aka the x-intercepts, which I've been talking about. Also could be described as the zeros of the function. I'll go to this first one and just highlight that. Those are the y values above. Okay. Intercepts, just a reminder of what they are. This notation, y-int, is just standing for y-intercept. The notation x/int is just standing for the x-intercept. And the y-intercept has a y-coordinate on the y-axis. That's right here in this graph. And the ordered pair is going to be 0 followed by the value of the y-intercept. So on this graph, we have a y-intercept value of 16. And the 16 is the y-intercept. It is just that value. If you write the ordered pair 0, 16 for it, I will accept it. Technically, the y-intercept is just 16. And what does it represent? Well, you read that the y-axis is about gas and gallons. The x-axis is about travel in miles. So that y-intercept, when x is 0, you haven't traveled anywhere, but you have 16 gallons. So what is the amount of gas when at the initial time? So the 16 is the amount of gas at the start. And then for x-intercept, it has an x-coordinate on the x-axis. So the ordered pair is the value of your x-intercept, comma 0. On the graph, that's, oops, moved it with my hand. The graph, it's right here at 320. And so, oops, the x-intercept has a value of 320. And so the distance traveled is 320, and notice that the amount of gas you have is 0. And so the 320 is the distance you travel before you are out of gas. Any questions, comments yet? All okay? All right. The energy in this room. Come on, we can do this. It's only Tuesday. All right. So moving on, page 2. So you're going to be given a graph, and they're going to ask everything. Domain, range, x, y intercepts, intervals where positive and negative, and intervals where increasing, decreasing. And so, first of all, this is a parabola. It gets wider and wider and wider. The domain is going to be all reals, negative infinity to positive infinity. For the range, you're going from the bottom up. So you're traveling this way, and the first value hit is right here, and you have to look at the scale and just take a minute to look at it, but it's going by tens. And so you are at negative 25, and that is included, and then it just goes up forever. So the range is negative 25 to positive infinity. Again, when you do intervals, always the smallest number on the left, largest number on the right. You can't put positive infinity first and negative 25 second and get credit for it. The smallest number goes on the left. We have x-intercepts. Well, the x-intercepts are here and here. And so they are 5 or, actually I want to put them in increasing order, so -5 or 5. Those are the actual x-intercepts. They are just the x-coordinates. I will accept if you write -5, 0, 5, 0. Now notice, in context, that is an ordered pair. That is an XY ordered pair. It is not an interval that we've been talking about. It's not an interval for a domain or range. So you have a comma, not a union symbol. We use union symbols for domain, increasing, decreasing, positive, negative. But when you're referring to an ordered XY pair, we're going to put a comma between them. The y-intercept is -25 or 0, -25. You need to review x-intercepts, the y-coordinate 0, while y-intercepts, the x-coordinate is 0. You need to know how to write those ordered pairs. Now, to the new topic for today. For intervals where it is positive or negative. Again, for the bottom 4 here, positive, negative, increasing, decreasing, where they are the same, we're going to use the leftmost x point farthest left and the x point farthest right for both of them. But for intervals where positive or negative, you use the x-intercept values as your boundaries. So I like to make a number line just below the graph and go, my farthest left x value is -infinity, my farthest right is positive infinity. And then I'm going to put the boundaries, the values that separate these intervals are the x-intercept values of -5 and +5. This is where we determine where it's positive or negative. And this graph is above the x-axis. It is above the x-axis, so here and here for these x values and these x values. Again, the function's above the x-axis here, so it is these x value, for these x values y is positive, for these x values y is positive. And so my answer for that, it's positive here and it is positive here. It is positive -infinity to -5. -5 is the x-intercept. On x-intercepts, the function is not positive or negative, so it's always a parenthesis there. Union 5 to infinity. 5 is also an x-intercept. We are not going to include those because the function is not positive or negative. It's going to act as a boundary. The interval where it is negative is right in here. So this is the interval where it is negative. Because for those x values, it is below. The function is below. So it's all these x values between -5 and 5. So -5 to 5 is where this is negative. The process for increasing and decreasing. So for those, increasing, decreasing, again, we use the far left x and the far right, just as we did for positive and negative, but it is the x coordinate of relative max or mins. And right here is where we have a relative min. And so I like to do a separate number line underneath where we did that positive, negative. And again, the far left is -infinity, the far right is positive. Excuse me, but the x-coordinate, it is the x-coordinate, not the y. The x-coordinate of that min is 0. And then we want to think about if I'm tracing this graph from left to right, I'm going down, down, down. From left to right, it's going down. So in that interval of x's, this function is decreasing. Well, if I continue to trace, so I was going down, 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 in that interval, the function is decreasing. From that minimum, if I start going from left to right, it's going up, up, up. So in the other interval, it is increasing. And these are similar kinds of processes that you do in AP Calc. In terms of doing a number line, identifying the boundaries that you need to use, and indicating for each interval whether it's going up or down. And so anyway, the interval where this is increasing, and this is why I want the number line, is because you got to be careful. Where is it increasing? Not the first interval as you're going left to right. It's from 0 to positive infinity. And on increasing and decreasing, always parentheses. There's never a bracket for increasing, decreasing. The interval where it's decreasing is negative infinity to 0. Again, the negative infinity must be on the left. Excuse me. All right, and this next problem is just introducing a process that you need as you move up in math, and it's starting with, it's pieces of a puzzle. And so you might start sketching something and have to erase because what you drew agreed with the first part of what's being listed, but it doesn't agree with the rest. So you are going to use this information and draw a graph that satisfies all these pieces of information. And so domain's all reals, range is all real, so we're going to have arrows indicating it goes forever and ever. It's increasing on its entire interval. So as you go from left to right, it's going up, 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 up. It can't ever hit a maximum and turn around and go down. There's no places where this is decreasing. It has an x-intercept of negative 2.5. Ooh, okay, I can put a point on here. Negative 2.5. An x-intercept means that you have the point negative 2.5, comma, 0 is a point on this graph. That can't move. Y-intercept of 10, it's going by 2 on the y-axis, 2, 4, 6, 8. 10, that is the point 0, 10. That can't move because it's a given. It is positives and then the negative. So if I go here at this negative 2.5, which is an x-intercept, those are the key things that a boundary point for positive and negative. The function is positive to the right, and it is negative on the left. So it's below from negative infinity to negative 2.5, and it's above to the right of negative 2.5, and it overall intercepts. Well, to me, that just means probably a linear function. Now, it doesn't have to necessarily be linear, but it has to continue to increase and not turn around and go back down. So there is a possibility, right? There's some other things. I could have had something that kind of curved, and that could work. You know, there are some other possibilities. All right, and then the last example. Relative max and relative mins. So on this, relative maximums are here and here. Those are relative max. Because in their little, if you just zoom in, zoom in, zoom in, zoom in. Oh, will it do it for me? Zoom in, zoom in. Zoom more, please. Or I guess that's it. In this vicinity, it is a highest point. That's a relative max. All right, we're going to just, come on, zoom back out. No, there we go. And that happens at that other point as well. The maximum for those is the y value. 20.372 is the relative max, and it occurs when x is negative 4.67. So the actual maximum value is the y value. But it's relative. It's not the overall. There actually isn't an overall max because it goes up forever. But there's a relative in that position. It is a max. And so, same with 3.9. There are two of them. All right, and then for relative mins, you have these 2 points. And so we have negative 4.24 when x is negative 0.674 and negative 9.632 when x is 5.927. Those are your relative mins. There isn't an actual max or an actual min because it goes to positive infinity and negative infinity. And then the zeros are here, 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 and here. And you have to be careful. It's going by 2, so it's negative 6. It's nice to go in order from smallest to largest. Then negative 2, then 1, then 4, and then 7. And you could write them as ordered pairs or just list the values, and that's good. And that ends those notes.